Hello, and welcome everyone to today's JMP academic webinar, JMP for Teaching Data Analytics. Today's webinar is going to be presented by Kevin Pochner, JMP Academic Ambassador. I'm Ross Matusalem, Kevin's colleague and fellow JMP Academic Ambassador. I'm here just to host and field some questions in the Q&A as we go along today. But in today's webinar, Kevin's going to give us an overview for the applicability of the JMP Student Edition software for teaching data analytics courses or in a data analytics curriculum, which can be pretty broad and cover everything from your basic statistical analyses and graphs through more advanced statistical modeling, maybe some machine learning, text mining, and a lot of other things as well. So the goal today really is to give an overview of the applicability of the JMP Student Edition for teaching these kinds of things. And so Kevin is going to be touching on a lot of different domains today to give you an idea of how well JMP might align with the needs of your course or your curriculum. Now, before we get started, I encourage all of you to submit any questions you have, big or small, at any point during the webinar today. Please submit those into Zoom's Q&A panel. So go ahead into your Zoom interface and find the little icon that you see on the screen in front of you and open that up. Typing your questions into the Q&A helps us keep track of them, also helps us answer them and reveal those answers to you in a threaded way that is easy to consume. Go ahead and use the chat for any general comments that you would just like to make to all of the attendees, but please do put your questions into the Q&A, and I'll try to answer them to the best of my ability as we go along here. So with that, Kevin, are you ready?
I am, and can you confirm you can see my screen?
Yep, looks good.
Perfect. And well said, Ross, about the data analytics courses. I would say it's probably the most diverse course out of all of them. It tries to cover a whole range of topics, whereas most traditional stat classes, I think, are a little bit more focused. Luckily, JMP has platforms and tools for all of the topics, and then some. There's a lot to cover, so I'm gonna jump right in, and I won't be able to cover topics in tremendous amount of detail, but there are other webinars we have in our webinar library and other resources to learn them. So I'm actually gonna just click here to point you to our resources. You're gonna get this journal in a day or two, along with a link to the recording, and these right here are links to some of our academic resources, but I'll just quickly show you by going to the website. So here I am on just the homepage of the JMP website. If you click on this menu item, JMP Advantage, down here, you'll see JMP in Academia. And under this faculty section, you'll see course materials. I'll click on this. Now, we curated a little bit by course topic. We sort of try to serve up resources that are most relevant to a particular course, but it doesn't matter because anyone you click on, you can actually get to all of the resources. But I'll just click on analytics and data science. And here's where you'll see books, step-by-step guides, case studies, enhanced data sets. Here's our webinar library, our interactive teaching tools, and our free courses and course materials. So encourage you to go there. And as I said, this webinar is going to be up in this our webinar library very shortly. Okay. So let's start off with a topic that I think is really great, and I encourage everybody to incorporate into their class just because students are so familiar with this kind of data, text analysis, right? Every student is familiar with social media posts, blog posts, movie, book reviews, product reviews. And so it's a type of data that everybody's already familiar with. And there's really no advanced knowledge you have to have about statistics. We're just going to count up words and score words. And I think any student can really understand it. So I'm going to open up this data set called coffee shop reviews. Now, this is actually one of our enhanced data sets, and I'm going to show you when you go to our enhanced data sets what you get. And put this on the screen here. So this is an example of our enhanced data sets. And basically what these contain is there'll be a storyline. Well, it'll also mention what JMP tools and stat methods you're going to see in this example. There'll be a storyline. This one happens to be about Yelp reviews for coffee shops in Austin, Texas. And so it will describe what the data is about, what are the objectives of the analysis, what kinds of questions we're trying to answer. It describes the data, and then it goes into a whole bunch of exercises that you can give out as an assignment to your students. And so really encourage you to incorporate these in class, because it really gives sort of a path of how to analyze the data. And I'll close this because I won't need this going forward here. Okay, so here's the data set. Now the exercises has you do a bunch of things, even with the scores, the ratings, and comparing it to the number of reviews for each coffee shop. But I'm going to go right to analyzing the text data. So these are the reviews right here. Our Text Explorer platform is under the Analyze menu. You put in the text data into that text columns field, click OK, and very quickly what JMP is going to do is it's just going to start counting up words and phrases. And so you can quickly see the most frequently used words to the least frequently used words. Now, if you haven't dealt with text data before, one of the things you have to do is you have to sort of clean up and massage the data a lot to sort of target in on things. And what I mean by that is, for example, notice the most frequently used word is coffee. And then coffee shop is the most frequently used phrase. Well, the reviews are about coffee, so that's not really informative or useful to us to know that people said the word coffee a lot. In fact, if I scroll through a little bit, I can see, oh, Austin is another word that's said a lot. Well, again, that's not really that helpful. So what you can do is you can click on the word or groups of words, and if you right click on it, you can do something here called make it a stop word. Now, JMP has a dictionary of stop words, so words like the and was and is, those clearly aren't going to be counted, but you can modify that stop word dictionary, and one way to do it is just by adding stop words, and then so those disappear. Now, something great you can do with any word you see here, you can right click on it. So I'm going to click on this word vibe. And I'm going to right click on it, and I can choose show text. And what's going to happen is a window is going to pop up, and I'm going to see every review where someone used the word vibe, and I can take a look at the comments and get a sense of what how that word is being used. Now, granted, it's used over 3,300 times. I'm not going to scroll through 3,300. The other thing you can do is you can combine words. So, for example, I'm going to take the word good, and I don't know, I'm not saying this is the best thing to do, but you sort of want to look at the reviews to assess if this is a good thing to do. But I might take the word good and nice. And if I look at those, you might realize, those might mean the same thing, right? Good coffee, good service, nice service. So what I can also do is I can combine words. And so I'm going to right click on those two words. Okay. And I'm going to click recode, and I can grab those two words. And I'm going to say group them, and I'm actually going to give it the new name good/nice. And when I hit recode, you'll now see that good/nice is there. Okay. Actually, I think I'm going to add, this is always a common graphic that people like to do, is the word cloud. And I'm going to choose to display it in this centered look. So this graphic is showing the frequency of words by the size of the word in this word cloud. So it's a nice way a visual way to summarize words that are used more or less frequently. Now, one of the things that is great to do in JMP, and part of the exercises in this enhanced data set, is it has the students target specific coffee shops or specific scores people give it. So what I'm going to do is I'm going to bring up the local data filter, and you can do this almost everywhere in JMP. And this is one of my favorite tools. And so what I'm going to do is I'm going to pick coffee shops and ratings, and click the plus button. Now over here, I have this data filter. And so now what I can do is I can pick, for example, an individual coffee shop. Now what I'm actually going to do is I'm going to order this. So it goes from the most frequently, the coffee shops with the most frequent reviews to the ones with the least frequent reviews. I can click on a coffee shop and then it's only going to use that data. And I can go over here and take a look at what are the most frequently used words based upon individual coffee shops. The other thing I can do is I can filter the data by a rating. So you see there's about 2,300 people who rated the coffee shop a 5. So if I click on that, now it's going to filter and only use those 2,300 reviews. So if I click on, for example, food and see what the text is for this, I bet I'm going to see positive things. Here we go. Food was great. Uh, uh, Great cafe and food. Food is delicious. Like you can go through here and you'll tend to see that the food will be positive. Now that's not the only reason why people give it a 5. So it's not to say that every one of those will be positive, but most likely the vast majority, are pretty close to all of them, will be. Now I'm going to click on the 1. Now there's only 82 reviews where people scored the cafe, gave it a low rating of a 1. And when I do that, take a look. Food is also the most frequently used word for all of those people. So if I click on food and say show text, what I'm going to probably see are things like yuck, the food is bad price, food was stale, no fresh food. And if I scroll through here, I'll probably see things that that are not positive. Fed the food to the pigeons. I guess, I guess that isn't that positive. So the exercises in this case study have the students go in and sort of target specific ratings and then hone in on specific cafes and start describing the themes. Now, something you can also do in the Text Explorer platform is something called sentiment analysis. And what's great about sentiment analysis is it's now going to go through and have a collection of words. And so JMP has a built-in dictionary of words, like you can see some of them there: awesome, awkward, awful, and it gives it scores. You can adjust those scores if you want. You can also add new words to that dictionary if you want. JMP has negation terms, intensifier terms, and it goes basically through here and it scores the documents that it has a word that's part of the dictionary, and then you can see the reviews, and it kind of summarizes it in some graphs. Now I've got it filtered here so you can, I'm kind of honing in on specific things, but now in this case, sentiment analysis is best designed when you have unstructured data and you don't have some kind of numeric score. But in this case, people are giving it a numeric score, so it kind of already can quantify it. But this tool is really great when you just have some unstructured data and you're trying to figure out how to translate it into something numeric. Okay, I'm going to close this example and moving along here. Okay, the next one I'm going to pull up is I'm going to show some graphical analyses. I mean, these are a part of, to me, every course. And I have a traditional statistics degree. And in that world, there wasn't as much focus on exploring data graphically. But I tell you, you can almost answer very challenging questions if you try to phrase it in a formal statistical method or model when it comes to just graphing data in various ways. And so I'm going to do that with an example here. This is another one of our enhanced data sets. Oops. This is another one of our enhanced data sets. And this one is about, I get a little crazy here with my mouse. This one is about math and reading scores for 4th and 8th graders. And this is something that's done by the Department of Education. They put out this annual report. It's called the Nation's Report Card. And so this is a discussion of that report. It describes, the kinds of reasons we're looking at this data, a whole bunch of exercises with JMP instructions. And at the end, in fact, there's a link to that website that shows that report. So you can actually direct your students to that and use that as a way to motivate the reason why we're analyzing this data. Okay, so let's create a couple graphs. Now, I have some graphs I already made, so I'm just going to open them up first so you see where we're going. And so one of the graphs I'm going to make is this graph right here, which is going to show a map of the United States. and the color of the states are going to be some value, and I'm going to have it, I can switch between math and reading scores, and then I can have a data filter where I can pick a given year. So I'm going to move this aside, and I will create this graph. If you haven't used this tool yet, now, granted, we have visualizations and graphics everywhere. Every single platform we have, we think there should be some visuals to help describe and interpret the results. But if you're just sort of creating a graph from scratch, not tied to a specific statistical analysis, the graph builder is pretty much the way to go. Think of the graph builder as a blank canvas waiting for you to make the graph. And so you have your variables listed over here, and then at the top is your little palette of different types of graphs. So I'm going to start building this. Now, if I grab state and drag it into the middle drop zone, well, JMP has states as part of a library of shapes, and so it's going to know, well, I'm going to show you a map of the United States because you gave me state names. If they were countries, you'd see a map of the world. If there were counties for, say, a given state, I would see that state with the map of all the counties. But in this case, it's the countries. Okay, now I want to grab one of the variables, math, and I'm going to put it over here on the color. And so now it's color coding the states by math. Now I haven't broken it down by 4th or 8th graders yet, or year. So it's just sort of taking the average of all of those years and the 2 different grades. Now, something I always like to do is I always like to scale this so that I like to put it on a quantile scale. I also like to make, do I have green? I'll choose that one. I can make others, but I'll just pick that one. And so this way, the more green it is, the higher it is, and then like kind of right in that middle, that gray, that's the 50th, that's the median, and then it's going in the directions of the quantile. So I'll do this. Now, I want to be able to switch between math and reading scores, and the way you do this is something called the column switcher. And so what I'm going to do is I'm going to say math scores. I'm going to swap it out with reading, or be able to choose between math and reading. And now you see over here, I have controls to pick math or reading, whichever one I want to show. Then I can come over here and open up the data filter. And I'm going to pick year and grade and do this. And these two together, the column switch and the data filter, I use this so many times. This is one of my favorite tools, because here's the thing. I can now pretty much plot every combination I might want to see in one graph. So I don't have to make an individual graph. So for example, I can pick a given year. So here I am swapping through the years. I can pick a given grade. So let's say 4th graders, and I can pick the particular subject, math and reading. And so now I can just click through and see. And if I grab multiple states, then it's going to, multiple years, it's going to take the average of those years. So I love that JMP does this, because you can have just one graph and then alter it any way that you want. Now, if you're brand new to JMP, if you want to save this report to your file, you go under this top red triangle. Hold on, I'm going to move this over here. I want you to keep an eye right here. So you go into the top red triangle, save script to data table. You give it a name. I'll just leave it as the default. And when I click OK, you're going to see the script added right there. Okay, so now when I close this, whenever I want to see it again, I just click the green triangle and it reruns the script and launches the output. Okay. I will. Now, another graph I'm going to make is this one right here. So this is a sort of a time series graph, so I can see the changes in the scores across year. I've got a panel for each grade. And I'm also going to set it up so I can swap the subject. And over here, I got all these data filters. And I'm going to, you'll see in a moment why this is a great way to do it. Okay. Sorry, let me get this onto my other screen. Okay, same thing. I'm going to open up my graph builder. Okay. And I will put math on the y-axis. And again, I haven't given any other information, so it's just giving me a dot plot of all those scores across years and states and grades. Now I'm going to set up the column switcher so I can switch between math and reading. So that's what allows me to put whatever variable I want on the y-axis. I'm going to put grade in the X grouping up here. So now I've got a panel for each grade. I'm going to put year down here on the X-axis. So now I'm seeing all of the scores. So again, all of the states and are there. And now what I'm going to do is I'm going to bring up my data filter again, and I'm going to pick, oh, I didn't step through the data, but in addition to having state, I've got region and division, so different parts of the country. So what I'm going to do with my local data filter is I'm going to pick region, division, and state. And go like this. And then I'm going to grab state and make it the overlay variable and add connect lines. I know I just did a lot there. I understand that. But the reason why I did this is because now I can pick an individual, well, I can pick the subject, but then I can pick individual regions or individual divisions or just sets of states, maybe individual states or a couple of different states. So this illustrates this idea that think of all the combinations that you might want to look at between all of these different parts of the country. There's, I don't even know how many graphs there are, whatever, factorial, if you multiply this by this by this. But JMP allows you to make just one graph, and then I can filter it any way I want and target and sort of explore the data. And the exercises in this enhanced data set have you do that. Okay. Now the last graph, and just for preservation of time, I'm just going to show you it and then point you to where you'll find this. So if you go under the graph menu, there's this tool called bubble plot. And this is basically allows you to plot a scatter plot. And I'm going to plot math on the y-axis, reading on the x-axis. And when you have a variable like time, what I can do is I can say, have this scatter plot change over time. And so now I'm watching the data change. Now, everybody noticed that, right? See how the scores are kind of increasing? And then between 2019 and 2022, boom, right there. Oh, the data notice goes every other year, but it skips 2021 we all know the reason for that. And there's a lot of cool things you can do with this. The way I have this set up is I can actually grab a particular part of the country and open it up, and then I can get the states for that particular part. And the same thing, I could set up the data filter so I could just pick individual states or individual regions or individual divisions of the country. So I encourage you to take a look at that enhanced data set when you're doing graphical analysis. It's a really fun one. Okay, close this guy up. We're doing okay with questions, Ross?
Yeah, we're doing okay for now.
Okay, perfect. All right. The next one I'm going to show is clustering, and this is a topic that I've seen a part of a lot of data analytics classes. In my stat degree, I didn't get this topic until I was taking an advanced second semester multivariate graduate level course. But this is a topic that I think a lot of students can handle it, and I'm glad to see data analytics classes incorporating this. Similar, you don't need to understand inference like p-values and confidence intervals. You just have to understand the idea of, well, things that are similar, we're going to group together. In fact, I like to joke that students learn that in Sesame Street, right? Where you have to pick which things belong or which things don't belong. So it's not a hard concept. This is a fun example because I think students can really relate to this. So this data set is about songs on Spotify, the top 100 songs in Spotify in 2018. And so each song was rated, and this is how those services work. They actually have people with strong knowledge of music, right? So people who've studied music will score songs across a whole bunch of variables. So you can see some of them here, like danceability, energy, loudness, speechiness, acousticness, all the way to tempo. And so this data would be an aggregate of like many, many, many people. It could be hundreds, if not thousands of people who scored these songs. Well, if I've turned these songs into numeric values, I can sort of start looking at them. And I'm going to run a routine called clustering, which is going to look at all of these numeric values in, let's see how many variables we got. 1, 2, 3, 4, 5, 6, 8. So the data is in 8 dimensions. Now, before I run clustering, let me just make a matrix plot. So I'm under our multivariate methods menu. And if you put in all your numeric variables, what JMP's going to do is it's going to calculate the correlation between all of those variables pairwise, and then show you all possible scatter plots. Now I'm going to close the correlation table just so I can make this bigger. Oh, the way I want you to think about JMP for those that are new to it, don't think you've run an analysis and you get a piece of static output. I want you to think you've launched an interactive platform where you're going to start doing more analysis. So anytime you do something in JMP, there's an initial set of output. Like in this case, I got a correlation table and a matrix plot. And everywhere in JMP, you'll see these little red triangles. So see these little red triangles over here. If you click on those, that's where you're going to get another set of menu items that are things you would do next with this kind of data in this platform. Okay. So for example, if I wanted to, I could say, well, let me fit a line to each of those. Not that I would do that here, but I can do that. Or let me add a density ellipse or non-parametric density. And so there's all sorts of ways I can modify this graph. The reason why I went here is when I'm teaching clustering, I like to start off by showing, okay, look at things that are similar to each other or different. So points that are close together. Now, again, I'm only looking at 2 dimensions here, but you can start to see, oh, you know what I'm going to do? I didn't do this yet. If you grab variables and I'm going to right click and I'm going to say label, unlabel, and then you'll see that little symbol right there. If you do that, now when I float my cursor over a point, it's going to tell me those names for those variables that I asked it to label. So I can go over here and float over individual songs. The other thing I'm going to do is I'm going to do a 3D scatter plot. Again, I often start with these kinds of graphs. I'm just trying to motivate to students how we can look at things that are similar and different. So we can see songs that are, actually, I'm going to make these points bigger. Oh, I know that I'm doing this quickly. If you're using JMP and you're wondering, hey, can you do X, Y, or Z? Double click on something or right click on something. And that's where menus will pop up and you'll see options. Like one of them here is I'm going to change the size of the points. I just want to make them a little bit bigger. Okay. So again, this is only 3 dimensions. The data is in 8 dimensions, but I can go through here and click through and look at all combinations of 3 variables. And again, identify songs that stand out, are very unusual, to songs that are similar to each other. But again, I'm in 8 dimensions, so it's a nice way to motivate it. But what I really want to do is run our clustering platform. And under the Analyze menu, there's clustering. And I'm going to choose the hierarchical clustering method. And I'm going to put in all the variables. And you've got options, like you can choose different ways of clustering. I'm going to leave the defaults here. Click OK. Let me see. I'm going to play around with this a little bit. Now, I know this is tiny, but there's always a little magnifying glass in JMP where I can grab that and I can zoom in if I want to look at a specific part. But what I'm going to do here, I'm going to do a couple other options here. I'm going to say color by clusters. And I have a little control panel over here, a little that I can move around to decide how many clusters I want to choose. And then I see those clusters color coded if I want. And again, the red triangle is all sorts of options that I might want to see. Like I might want to save this cluster solution. There's other visualizations that might be handy to look at, like constellation plot is another way. Now, the reason why this is hard to read is because I told JMP to put the name of the song there. And so that's kind of why it's getting a little crowded. The reason why I think this is a really fun example for clustering is, let's face it, students like music, right? They're going to identify this. They may know most of these songs, if not all these songs. And what you can do is you can maybe grab some songs that are similar to each other by this method. Let's say, I'm just going to kind of go in here and pick something. Let's see, I'm going to try to grab, I'll just grab a group of songs here. I'll grab those right there. And so when you highlight that set of songs, they're going to be identified here in the table. Well, what you can do is you can go listen to the songs, or I guess in class, you can just go play, you know, a short part of each song and kind of see like, oh yeah, I see why those are similar, because they have similar scores across these 8 variables. And it's kind of a fun way to sort of verify like, yeah, I actually agree with the clustering solution. And that's how these methods work, like Pandora and Spotify, because if you listen to a song, let's say you're listening to that song right there, and that's Havana by Camila Cabello. If you listen to that song and you give it a thumbs up, I don't know if any of you guys have listen to any of those music services. Well, what's going to happen is, using methods like clustering, they're going to say, well, you know what, this song right next to it, I'll click on that and see what the name of that song is. What Lovers Do. Okay, I made it a little inappropriate, but nonetheless, that's a song by Maroon 5. Well, it's identifying that that song is similar, and it would serve that song as a candidate song that you might like. And now, again, you thumbs up and thumbs down, so you're sort of telling the service and the algorithm whether you like it or not, and it's sort of adjusting, so it does get into some prediction, and you kind of verify, but it makes sense why it would serve up a song. It's not going to get it right all the time, but it's a good chance you like it because it's a similar style. No, the other thing I'd like to do with clustering, it's in addition to thinking of it as grouping things that are similar, I think it's fun to identify things that are different. So for example, you could I'll grab this group of songs over here, and then maybe I'll go over here and grab this group of songs. Oh, you know what? I want to pick 2 colors that don't look alike. Here, I'm just going to pick these two clusters. Okay, so I'm going to grab these 2 clusters. So there's 4 songs in one. I think there's 5 songs in another. And what I'm going to do is I am just going to subset these out just because I want them into a data table here. And so now I have 2 groups of songs that are considered, these 2 groups are different. And what I'm going to do is I'm actually going to make that matrix plot of those. And so now I can look at these songs relative to these variables. Now, again, these are just 2 dimensions at a time, but if I wanted to, I could go to the 3D scatter plot and do 3 dimensions at a time. Let me make these points a little bit bigger so you can see them. And I can look at these songs and see what makes them different. How do they stand out? What are some of the key variables of why they're different? And then I can go listen to the songs and sort of decide if I agree or not with the solution. So I think this is a really fun one for students because they can go actually check it out. And if you have ones on things like movies or TV shows, that's another example of ones where you can actually see what you think of the clustering solution. Okay, I'll close this example. Ross, how we're doing?
We're doing well. We do have a question that came in about the local data filter, and specifically how to copy a local data filter from one report window and paste it into another. Do you think you have a minute to demonstrate that for us real quick?
I've never done that before,
Okay,
actually.
well, it is possible. See, this is one of the fun things about Jump, everybody. You use it forever and you still learn new things. So go ahead and pop up a report window there.
Yeah, let's get
Just a distribution or anything simple, and apply a local data filter. Oh, you already have one. Great. So then under the red triangle, you'll see copy local data filter all the way near the bottom.
nice.
Okay, and now open up a new window from that same data set. New report. All right, and then under the top red triangle, actually, so it'll be not the local data filter one, but graph builder. Well, remove the existing local
Oh,
data
yeah,
filter. I
okay.
think you can't paste it if there's one in there. So let's imagine you're starting from scratch. And now there's right there towards the bottom, right above local data filter, is paste local data filter, and that will paste the one from the previous window.
Nice. This is the thing about Jump. So I've been using Jump now for about 6 years. Every time I'm either watching a demo or in this case I'm trying to do a demo, there's some other little feature that I didn't know that Jump could do, and there's just so many of those where it really just streamlines using the software and doing analyses. There's always little tricks like that. Okay, great. Let's now move on to modeling. Now, there's a webinar coming up in 2 weeks that's entirely about predictive modeling, so I encourage you to attend that. And if you go to our academic webinar library, that's where you're going to see, I'll go to our webinar library here. There's a collection. I don't know how many we have there, Ross. You say about maybe 50 or so. And so this is where you can focus on specific topics. For example, I introduced clustering. Well, we have one on clustering and multivariate methods. We have a whole one on text analysis. I've introduced that, but you can go in there and see more. Okay. Okay, so the example I'm going to do for modeling, this is a data set I got from the UC Irvine data repository they have. And it's about, I got a little description actually of what the data is and even references the paper. It's basically the performance of high school students in, I think it's Brazil. That's my guess. I don't think it's Portugal. I think it's Brazil, but regardless. And what we have here is 3 grades during the 3 periods, which is kind of times of the year. And I think it's on a scale of 0 to 20. Yep. And for each student, you see there's 649 students. For each student, in addition to their grades during the 3 period, we have information like, well, what school is it? There's 2 different schools. What's their gender? What's their age? Actually, when you go to look at this data set, when you click on it, I've got the little note of what each variable is about. So there's things like the family size, what's their parents' education, what's their parents' job, do they have a guardian? Is it their parents or someone else? What's the travel time to school? How much time do they spend studying? How many failures did they have during the year? And also things on their social life, like are they in a romantic relationship? How much time do they spend with friends? There's even variables about how much alcohol that they consume and how many absences. So there's a whole bunch of characteristics about each student. And what we're going to do is we'll see if we can predict what their performance might be based upon those attributes. Now, something I like to do a lot when teaching modeling is I like to define different times when you would be using the model and have students pick the best model for that. So for example, let's say you were trying to use this some resulting model you build to predict how they're going to do during the first semester of the year, and the student hasn't come in yet. All you know is the attributes about things like, well, what school they going, what age they are, what gender, things about their family, but you don't know anything about the students, so you don't know anything about, well, do they have a romantic relationship or not? How much time do they spend studying? Have they had any failures or not? Because the school year hasn't even started. So I like to sort of do that because you're like realizing at some point in time, you can't have all the variables in there, even though they might be the best predictors. In fact, you would see if we looked at this data, in fact, I'm going to do that. I'm going to do a little multivariate of the 3 grade periods here. So I'm getting the matrix plot of the 3 grade periods. you can see that there's a strong correlation between the grades. So your best predictor of how well you're going to do in your third period is going to be how well you did in the first and second period. But that's going to trump anything with regard to all the other variables. So again, the decision is, when are you going to make the prediction? Are you trying to predict the third period after the second period, or are you trying to predict the performance across the year before the student has even started the school year? That a classic one is in predicting defaulting on a loan or a mortgage. One of the biggest predictors is how many times you've been late with your payment. Well, sure, that you could use that along the way, but you couldn't use that at the time of somebody applying for the loan because you're not going to know that information. So I kind of like to incorporate that just to get students to kind of sort of be practical about it and think about how something's being used. Now, the other reason why I made this graph is there's a bunch of students who have a 0 or very low score. I think there's like a couple ones. I'm actually going to take those out. So I can highlight data inside of a graph like I'm doing right here. And if I want, oh, missing one right there. So I've got all those data highlighted, the low scores. And those rows, there's 15 of them. You can see 15 rows I've highlighted. I can say rows, hide and exclude, and you see how it just removed, oh, there's another one in there. Rows, hide and exclude. So I've chosen to take those out of this particular analysis. They're kind of anomalies and I don't want to incorporate that in. The other thing I can do, and what I'm going to do here is I'm going to open up, I basically created a graph plotting the scores on the y-axis with the column switcher, so I can pick grade period 1, period 2, period 3. And then on the x-axis is, well, I put one of the variables and then again use the column switcher. And so now I can just switch between any variable. And so I'm just starting some initial exploration. So here's an example of failures. So you see the more failures they have, their grades seem to go down. Now, a lot of the differences are very subtle. I'm going to rely on some models to pick it up. That could be one right there. So this was just a way to explore the data. Another reason why I like to do this is, let me go back to age. I'm noticing I've got students that are 19, 20, 21, 22 years old. Those are going to be quite different than your traditional high school student that's going to be between 15 and 18. So what I'm going to do is I'm also going to take these guys out. So I can grab them. And those are highlighted in the data table, and I can hide and exclude those as well. And you'll see that those are gone. So I was looking at some graphs as a way to see if there's any anomalies in the data and deciding if I want to exclude those or not. Okay, so I'm going to build a couple different models here. And I'm going to start off by building a linear regression. If you're building a simple linear regression with just one variable, you can use our fit y by x platform. But if you're building a multivariable regression like I'm going to do here, you need to go to our fit model. And I'm going to, let's see which one I want to do. I'll predict, how about I predict, I'll predict grade period 3, so how the students finish the year. And again, I'm going to just throw in all the variables, even though in practice, I like to see if the students can sort of narrow that down to only the variables that they might know at a particular point in time. Oh, the other thing I did is, I'll show you how to do this. I created a validation column where I split the data between training and validation, so I can use that method of fitting a model to part of the data and then seeing how well it does to data that wasn't used in the model fitting. The way you create that column is under our predictive modeling menu, there's a make validation column. There's some options you can do, like you can make sure you create equal percentages across some other variable. But basically, you can go in here and pick the percentages to put. You can even have a third partition, the test set. So that's how I created that validation column. I did 50-50. So what you'll see in all the modeling platforms, you can put in a validation column. Now, what I'm actually going to do is I'm going to try to automate this model fitting process. And so I'm going to use JMP's stepwise routine. And I'm going to hit run. And what it does is it launches the stepwise platform. It hasn't done anything yet. It's just set up, ready to go. And so I can pick, for example, do I want to do forward or backward elimination? Which criteria do I want to use? Do I want to use a p-value threshold? I'm going to use this one here, maximize the validation R squared. So it's going to fit a model. And when it can't make the R squared in the validation data set any better, it's going to stop. And I'm going to do forward selection. And so what I'm going to leave it here forward, and well, I'll do one step first, just so we can see which one pops up. Step, which one was the first one to come in? Aha, number of failures came in. Okay. So that's the biggest predictor of using this method, is if you have 0 failures versus other failures. And so this brings back that concept. If you're like, hey, build a prediction model so we can see how students will do when we just know characteristics about them, but we don't know their performance in the year yet, well, we can't use that variable. But in this case, I'm gonna let every variable have a chance to get in. And I'm going to hit the go button. I mean, I can do step by step. You know, when you're teaching, sometimes that's nice so people can see what's happening. But I'll just hit the go button. And it went in there, and you see how it found those variables to include, and it stopped when it couldn't make the R squared any better. And then I can say, make the model. It brings me to the fit model dialog box with all those variables in there. I'm going to choose minimal report, run, and then here I have the model fit and the classic output you would see, like things like R squared, my equations, the ANOVA table. Down here, I'm going to close some of these up just so we have less on the screen. And so down here, I can see I've got R squared for the validation and training data set. Usually validation is smaller, as it is here. I can see that a little over 27%. And here's my red triangle, all sorts of things I can do. Like, for example, I can say, well, let me plot the actual by predicted. And so I have a graph here of the actual values versus the predicted values. I can see there's a lot of variation. Remember, I'm only explaining about 27, 28%. Something I like to say to students when R squared isn't a large number, because obviously, people want to see things like 80, 90%. And then some students will be like, well, this isn't that helpful. And I always like to say to students, well, before you analyzed your data, your R squared was 0. So you certainly did something. You got 30% explained. And with social science data like this, it's kind of unusual to get very high R squares anyway. This is in like science engineering applications and running experiments in a lab where you'll get much higher R squares. But here are all sorts of options. I can do model diagnostics, like looking at the residuals. I can save things like the predicted values, the residuals, prediction intervals, confidence intervals to the data table. I'm going to open up one of our visualizations called the profiler. And so any model you build in JMP, you can ask for this profiler. And now it's giving me a visual representation of where I can see each effect, right? So I'm basically seeing the coefficient, showing the slope for each variable. And I can either interactively drag these around, or I can go in here and click on the values and type in numbers. And then over here on the left is I have the prediction with the confidence interval around it. And if I want to save this to the data table, red triangle, save script to data table, give it a name, hit OK, and now that's added. Now, in the next webinar on predictive modeling that's going to come up in 2 weeks, there's going to be a focus on how you build a bunch of models, and we have platforms in JMP designed to compare and contrast models. So I'm not going to do that. I'm going to build a couple different models, but I'm going to save really doing a comparison method for that webinar. So, but I'll just run a model from our predictive modeling platform. And so I'm going to go into predictive modeling. So we've got neural networks, partition decision tree methods, bootstrap borers, k-nearest neighbors, support vector machines. So a lot of these modern modeling methods. I'm going to do partition. And again, same thing. I'm going to throw in all the variables. Whoops, forgot absence. Okay, my validation column, click OK. And nothing's happened yet. It's just launched the platform. And now I can choose to just hit go or step one by one. And when teaching, I think going one by one is nice because then you can see actually what's happening. So if I hit split, what do you know? Same thing as what linear regression picked as the most important variable, whether they had failures or not. That's the split that creates the biggest difference in the average score in the third period. I'm going to split again. Now I think this is if their parents have higher education or not. I could look, but I think that's what that one is. Hit split again, and you see, oh, this is I think mother's education level, if they're male or female. Um, I'd have to look to see what each one of these, but I'm building that tree, and just like I showed you in linear regression, I can open up the profiler. Now here it shows every single variable, even the ones that haven't been put in yet. So I can see the ones that are just flat. And here I am changing ones. Here's the one with number of failures. Here's the male and female. And so if I go through here and go to the variables um, that are in my model in this tree, I would see that I can make a change in the prediction. Okay. So I said you can build a whole bunch of different models, but in 2 weeks, the webinar is going to get into showing these. And then what is very important is you can fit a bunch of different models, and we have tools that are focused on comparing those models, so we can compare and contrast the metrics like R squared, and also compare the profilers to each other. So I'll save it for then. Okay, I'm going to move on to Python integration. How we doing, Ross?
Doing pretty good. We just got one question coming in, and sorry, I've been typing while you were also presenting, so maybe you just showed some of it, but the question was just general. How do you get the details for what type of model provided the best fit?
Yeah, so in this case, when I've got numeric outcome variable, one of the key metrics R squared, which is basically just looking at your remaining error to the total variation. And so in this particular, I would there's an R, you'd see an R squared in every model you fit, and I can compare. But in the webinar that's coming up, they'll actually produce a table where you'll see all the R squares next to each other for each model, and you'll be able to pick. If it was a categorical outcome variable where I was trying to predict, say, a binary outcome like yes or no, then what I would see is what proportion of times did a given model get the answer correctly, and what proportion of the times did it not get the answer correctly. Okay, I hope that addressed that. Now, this is very exciting because you can integrate JMP and Python together, and that's powerful for a couple reasons. One of them is I'm going to show that we're going to run a routine in JMP that JMP doesn't have. But I have the Python script for it, so I will just run that routine. Now, there's a link here to a webinar in our webinar library we have that's an hour-long presentation on this. So I encourage you to look at this if you have an interest. But what I'm going to do is I'm going to use this. There's a statistical method called isolation forest, which basically looks at data from a bunch of variables and tries to find out identify anomalies, so unusual observations. And I actually put links in here to some stuff I found online if you really wanted to read up about this method, but just basically think of it as trying to find some anomalies. And just to give you an idea what that might mean, so I've got 5 variables here, and I'm just going to do a matrix plot. And if you look at this, you can notice, or at least as I look at 2 dimensions at a time, you can see the data looks like it's in these little groups here, but then I can notice that there's points that are sort of unusual. They're different than that, and they kind of stand away from those groups. So I can look at it in 2 dimensions. I could also look at it in 3 dimensions. And so what this routine does is it tries to identify those points that are sort of different than the rest of them. But it's going to do it in 5 dimensions. And so basically with inside of a jump scripting window, I've got a JSL script here. And what it's going to do is it's going to call this routine that we have written in some Python code in a library to run isolation forest. So all I have to do is click run script, and it's going to run the analysis. And part of it is to create a new column in the jump data table, identifying if it's an anomaly or not. So when you get good at this, you can actually script something in our scripting language where not only are you going to run a Python routine, but you might even have it so a dialog box pops up, right? So kind of, like might do something like this, and the dialog pops up where you put in all the variables and options that you want to do, and you can even set it up so maybe an actual jump report comes back as the output. So now you're back in the interactive nature. So this really expands jump capabilities. In fact, whenever I meet somebody and they start saying, "Can jump do?" I just go, "Yes." I don't even need to hear the end of the sentence, because I'm like, well, because we can run Python, or we also do R and MATLAB. So we can expand jump beyond the routines that we have built into the platform. Now, just to show how well this did, I'm going to open up the multivariate matrix plot. I'll open up the scatter plot, and let me slide this aside so I can click on it without getting in the way. And so I'm going to just highlight the data values that this routine picked up as anomalies or not anomalies. So you can see all the ones that are highlighted. So it's in those two groups. And then these are the ones that are identified as anomalies. Now you might look and say, well, wait a minute, those don't look unusual right here. They look like they're right in that cluster. Yes, but this thing is in 5 dimensions. This graph right here is just in 2 dimensions. So if you looked at this data in 5 dimensions, it would find those points standing out. But unfortunately, we cannot see in 5 dimensions. Okay. So the point I wanted you to get there was that we can embed Python code inside of a script window, a jump script window, and use that to expand the capabilities of jump. And I encourage you to go to this webinar we have here that I believe you did that one, right, Ross, if I'm not mistaken?
Yep, sure did.
Yeah. So there's an hour-long discussion. I think you do a lot of fun things, like you bring in data sets where it's file formats that Jump can't read in directly, but it can through by integrating it with Python first. Now, I'm not going to show this, but I want you to know that this exists. So there's an add-in we have to be able to do torch deep learning. And if you click on that link, it will send you to our Jump marketplace where you can download this add-in. Whoops, I must not have pasted that in correctly. Apologize. I'll fix that. And this is where you can download the add-in. And we even have, again, here's a link to a 1-hour demonstration video about torch deep learning. But basically what it does, and I'm just going to open up the data set I have, is this data set happens to, I'll make these pictures a little bigger. This data set happens to be about the manufacturing of these metal parts, these little discs here. And basically, the images were looked at, or I should say the parts were looked at, and they were classified as either being defective or not. So I've got this column, if the part was defective, and I've got this image. And if I let me look at one that's defective here. I'll make this a little larger. So here's one that's defective, and it looks like it's defective because you see all that little extra metal material kind of on the edge there. Or you might see things like this where there's a little pit mark there. So if you scroll through all of these defective ones, you'll see some issues with it. So there's one with sort of that edge there that makes it not good. And if I scroll down to the bottom and look at the good ones, you'll see that they don't have any of those deformities that I was seeing. Well, this torch deep learning add-in, you can have Jump build prediction models. You're not even telling it what to look for. It's going to look at these images and see if it can find patterns in like changes in contrast, changes in shape, gradations, marks, things where stuff isn't uniform. And it comes back with a model that can try to predict the outcome based upon the images. And then going forward, now that you have this model, well, this equipment would be set up where it's just taking an image of these parts, and the model is trying to make a prediction if it's a good or bad bad part. So don't have time to show it, but I just want you to know that this exists. And this, in a way, is kind of like an example of expanding JMP. And so an add-in was built. So it's not in the main platform of JMP yet, but an add-in was built. And people do this. If you go to our community, you'll see that people will build add-ins to do things that are not tools in JMP yet, but expand JMP. Sometimes we start off building add-ins first, and then in a couple versions, once we've tested it out, we actually put it in our platforms. Okay, that was a lot to cover. Thanks for your patience. I had to squeeze all that in very, very, very quickly. But I do not have a meeting after this, so I am free. So if anybody wants to hang on, if they have any questions, or they want me to go back to any of these examples and show stuff in more detail, I would be happy to do that.
Great. Well, thank you, Kevin. Everybody, thanks for coming to this webinar. Yeah, any final questions that you have, definitely please type them into the Q&A now. But, just to reiterate the big point that Kevin has, I think, made throughout here, JMP and the JMP Student Edition really is full-featured software that covers really the entire data analytics course or curriculum. As you can see, it's all point-and-click, visual, and interactive. So if you already teach with JMP, hopefully you learned about some new tools you can use. And if you're considering teaching with JMP, hopefully what you've seen makes you think it's worth maybe investigating further. And if you want to, we're always happy to talk about JMP and its alignment with your course. So you can email our team at academic@jump.com to talk to either Kevin or I or one of our colleagues to learn a little bit more.